So 6.4 and 6.5, they are divisions of fractions, and 6.4 is one of the interpretations. The question is asking for how many groups, but in 6.5, the question is asking how many units in one group. So we can look at these two problems together. And when we divide fractions, again, because they want us to ask the question how many groups. So that means this question mark here, whatever the question we're going to be to ask, that's going to be number of groups. So for fractions, oftentimes we can pick for groups, we can pick servings, or we can pick batches of recipe. Servings. So here in my example, I use the servings. So that's going to be my groups. Now, and the first number is again always the total number of units. Total number of units. So we also have to pick something for units. And measuring units, you can pick cups or liters. So in this example, I picked the cups, but in my second example, I actually picked the liters. So any measuring units you want to use, and depending on your work, what project, what object you're talking about. Again, so because the question, and this is a division problem comes from multiplication, so the number of groups is here. That means the other number has to be the number of units in one. So this number right here means number of units in one group. In one group. And again, units means cups in my case, and groups means servings. So I'm gonna go ahead and put cups here and serving, one serving. So now with all the everything labeled, you can come up with the word problem easily. So you can say I have 1/3 cup of something. I use the cheesy popcorn, and you can say flour if it's recipe, or cups of cereal, anything. And the second number is the number of cups in one serving. So we have 4/5 cup in one serving, where you can say one serving is 4/5 a cup. The question you're going to be asking number of servings. So how many servings did you eat? So we have the word problem. Now we're going to solve the word problem by using a drawing. So we start with, and because here both of them are cups, so we're going to start with the 1 cup as the whole, and divide the first 1 cup into 5 equal parts and shade 4 of them. So that's 4/5 of a cup. And the second 1 cup into 3 equal parts and shade 1 of them. So that's 1/3 of a cup. Notice that the size of the parts are different. So we have 1 part here, but we have 4 parts here. But they have different sizes. So we cannot really say, okay, this is what we ate. This compared to the yellow parts, 1 out of 4. We cannot say that because they have different sizes. So we have to turn it into the same size as pieces. So to do that, we learned from chapter 2, we can use common denominator. So the denominator 5 and 3 can be both turned into 15. So by multiplying 3 and the first fraction, multiply both the numerator, denominator by 3, and the second one by 5. And now we, whenever we multiply a number, it's equivalent to dividing each part into smaller parts. So again, we learned this in chapter 2. And so we did this one times by 5. So divide each part into 5 equal parts here. So now we have those tiny rectangles, strips, they have the same size now. So now notice that we got originally we had 4 parts, but now it's turned into, I guess originally we had 4 parts, but now it's turned into 12 parts. Originally we had 1 part, but that is turned into 5 parts now, the shaded part. Okay, again, after we convert it into the same size, we can forget about the size, which is 1/15 now, but the size doesn't really matter anymore. All we compare is going to be the number of parts. So we ate 5 parts, but 1 serving is 12 parts. So if you compare 5 parts to 12 parts, we ate 5 out of 12. So that's why the answer is 5 out of 12. So we ate 5/12 of a serving. Now in the second question, it's kind of similar. So you can actually use the same word problem and just replacing the numbers. And of course you have to, because we want to come up with how many units in one, so we also have to switch the number of units and the question and the information. So here we want the question to be how many units in one, number of units in one group. Again, the first number is still going to be the total number of units. And the second number, because the question is going to be number of units in one, which means this has to be number of groups. Again, these two numbers, one of them is going to be number of groups, the other is going to be number of units. So this is number of groups. Now let's pick something for the groups, something for the units. Again, I think I still did a serving for the groups. So the group is going to be, one group is going to be one serving. But for units, I think I used the liters this time instead of cups. So that's the liters. So here units becomes liters, groups becomes servings. Okay, so you can plug in the numbers now. So we have 1/2 liters of something, sports drink, and that's the number of groups. So which means, again, the group is serving. So that is 1/3 of a serving. So if you have 1/2 liter, that is equivalent to 1/3 of a serving. So the question will be how many liters in one serving? Okay, so we can use the join method to do it, because they actually ask you to use one of these methods, so you can pick one of them. So what we do is we're going to draw, because we have the question is asking for how many units. So we're going to, or the number of liters. So the number of liters is unknown. So what we're going to draw is we're going to draw the strip diagram for the servings, because we know both servings. We know 1/3 of serving. We ask for one serving. So we are going to draw. So we start with just a rectangular box, and that's considered as one serving. So the entire box is one serving. Because we want to draw 1/3 of serving, we divide the box into 3 equal parts. And you can, right now, don't worry about the inside number. So this is one serving, and we divide it into 3 equal parts. So one of them is going to be 1/3 of a serving. So that's 1/3 of serving. Because again, we have two different things involved. One is the serving, the other is liters. We cannot really draw both using one diagram. So again, the box represents the serving. So where did we put the liters? We're going to put the inside. So 1/3 has 1/2 liters here. And because notice that they all have the same size. So this part must also have, every 1/3 is equivalent to 1/2 liter. So this is also 1/2 liter. So now the one serving, which is the entire box, apparently you can see 1/2, 1/2, 1/2. We have 3 1/2s. So it's 1/2 times 3, and that is the answer, 2/3. And notice that we were supposed to divide by 1/3, but we were able to, by looking at the diagram, it's equivalent to doing 1/2 times 3. So it's kind of like inverting and multiplying. So you invert this number and change division to multiplication. 1/3 becomes 3/1, because 3 means 3/1, and then you do multiplication. We can also use the table method. So 1/3 serving corresponds to 1/2 liter. The question is, one serving equals how many liters? And notice that in order to turn 1/3 serving to one serving, we just need to multiply by 3. Correspondingly, we're going to multiply the quantity of liters by 3 to get how many liters. So again, 1/2 times 3. It's the same solution. For double number line, it's also very similar. So first you draw 1/2 serving corresponds to 1/3 serving corresponds to 1/2 liters, and then 1/2 liter. And then, well, how do we get one serving? So you're going to draw 2/3, so about the same size. So that's 1/3 from here to here. That is 1/3, and 2/3. The size is a little bigger, and then 3/3. That will give us one serving. That's the bottom number line. Now let's look at the top number line. So 1/2 liter You double it, 2 half liters, and you triple it, you get 3 half liters. So again, you have 3 1/2. You double, triple. So if you triple, means 1/2 times 3. So again, all these 3 different methods tell us you can always take 1/2 times by 3.